Okay, let's see what we got in the mail today. This bag of goodies. What is it? Oh, there's a note in there. What do we got? Some old capacitors, good old X capacitor, and some power thingies with cooling stuff. Very interesting. And here what we have. Okay. More capacitors, bake resistors, 7 watts, 15 ohm. Very good. And here an old bag with resistors. Engelse drop. Capacitors. What's it? FCH 191. What's that? Fun. FCH 191. FCH 111, 191, 191, 191, 161, 191, 161, 161. E50, 2E50, 4G50. Very interesting. What's this? I don't know. So I looked up the FCH 191 and turns out it's a quad NAND gate. Each NAND gate 2 inputs. So it's a little bit like a SN7400. And the 161, the other one, which I have 3, is a triple NAND gate. Is that right? Yep, triple NAND gate. And I found a datasheet on the internet which is from Mullard, which is to produce tubes, and that datasheet is from 1976. So that's very interesting. And these things are diode transistor logic. That's DTL. DTL was the predecessor of TTL, transistor logic. So this predates the SN7400, which was transistor logic. But now let's come to the main course, which is this little bag, and it contains 4 huge things, and this is the reason I ordered this. I bought it from someone. These are huge things, and they are logic chips in essence as well. Well, maybe it's not chips, but let's see what we got. If and when I can get them out of the bag. Right, there you go. Well, they look like normal dual inline package, but they are just huge. If we compare them to the normal sized dip package, look at these things. They are so big. And well, this is what is it? 74 LS193. That's the same size. Well, it's 2 more legs. It's the same size as the FCH 161. Look at this. This is an SMD and a small outline package, I think, which is the pin size. The pin spacing is half that of a normal dip package. And this thing is just double that. That's huge. And beautiful red color, by the way. So what are these things? This is TU60. This is an 2NOR60. 4NOR60, and this is another 4NOR60. So the 4 NORs, they contain 4 NOR port gates. And the 2NOR contains 2 NOR gates, and the TU60, I'm not sure, but there's a note. 2NOR60, 4NOR60. The TU60 is a delay unit, and the delay is determined by an external resistor and capacitor. Well, let's look up some details on the internet. As you can see, this thing has 17 pins, which is staggered. It turns out these things are actually breadboard friendly. That's very funny, because the spacing of the leads is twice the spacing of the normal spacing, which is 1/10 of an inch. So these are spaced 2/10, 1/5 of an inch. And the funny thing is the leads are staggered. So it means that this pin here is in the first row, and this one is in the second row, and then this pin is in the third row. And another thing that's very funny is the pins are numbered, and the numbering starts at the top left with number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh no, I'm doing it wrong. What is happening? Oh, 10 is here on the left. 10, 11, 12, 13, 14, 15, 16, 17. So they have an odd number of pins, and the numbering starts at the top left, goes to the right, and then continues there, and it goes to the right again. And not none of that counterclockwise rubbish. It fits very good. They are powered from an unstabilized 24 volt DC, and there's a number of data sheets on the internet about these things. They were made by Mallard, also the same that produced these chips, and the data sheet is dated June 1973. And they're not as old as I thought they were, because these things were from the 60s. So I would have expected that these things are still older, but they're not. 1973. This is actually resistor transistor logic. So the NOR gates are made by means of resistors which are tied to the input. So you can see the 4 resistors are 1, 2, 3 and 4 on the left. They form the actual OR gate, and the transistor forms the NOT. These things are more modern in technology, diode transistor logic, and these big things are resistor transistor logic. So that's an older technology. So we're going to do a little experiment with the 2NOR60. I brought in this ancient power supply, Delta Electronics from Holland. Turn it on 24 volts, and I'm going to turn it on. And what I did, shift it in a bit. So, the 2NOR60, 4 switches, and a LED, and a resistor. So what I did was connect the 4 inputs of one of the 2 NOR gates to the 4 switches, and tie the output to a LED. And what do we see? When all the inputs are not connected, they are more or less low, the LED is on, and when I press one of the buttons, the LED goes off. true for all four. I can push two simultaneously. That works for all four of them. Oh, you can't see it anymore. Yeah, there he is. Push. Okay. Well, that's so much for this experiment. So I built a circuit with the 2NOR60. It's a stable multivibrator with two LEDs. And let's see what happens when we turn on this switch. Yeah, hello, it works, hooray! Well, that's it for now today. Bye bye.